assume that you run a very efficient business. Everything you produce gets sold. There's no inventory. All right. So X units, X widgets, whatever, X units are produced and sold, and there's no inventory. Very simplified model. All right. Well, very often in business, we want to maximize P of X. What's P of X? Profit, your net profit function. All right. Profit is what minus what? Money in. What's money in? Revenue. Money in is revenue. Okay. Minus expenses, costs, C of X, or costs. Okay. And that includes fixed costs like the building, right, or the lease or something, right? Okay. Machines, maybe you buy machines, right? Those are fixed costs, and then variable costs like labor, right? Okay, the hours that people work. Right. Okay. So profit equals revenue minus costs. That's dollars out. Right? Dollars out. Costs. Profit equals revenue minus costs. Okay. Blah blah blah. I'm going to go straight to P prime of X. Okay. P prime of X corresponds to, well, of course, it's the derivative of the profit function, but we can think of this as the marginal profit function. Okay. And what is the marginal profit? It's basically the change. Okay, it's approximately the change in profit if we go from producing X items to X plus 1 items. So basically what happens if we produce one more widget? Okay, what happens to our profit? And really this is based on the idea of differentials. Okay, so I'll explain it this way. In my notes I made comments about marginal cost. By the way, we have marginal profit. Okay, C prime is marginal cost, R prime is marginal revenue. But we tend to focus most on marginal profit. Okay, now just as an example, all right, so let's say that this is a y equals P of X. So let's say that you're at X units here. I'm using X kind of generically. But let's say you're at X units there, maybe 60 units or something. All right? And we want to know, well, what's going to happen if we go to X plus 1 units? All right? Now, of course, the easy way to do it is, work out P of X plus 1, work out P of X, and take their difference. But sometimes the profit function is hard to state, okay? So we might have to rely on derivatives, rely on tangent lines. Now the hope is that the tangent line does a good job of approximating the profit curve, at least around here, at least in the neighborhood, in the vicinity. Okay. So it really is like a differential idea. The idea that, remember this picture, right? The run is 1, okay? So we have this picture here. The run is 1, okay? Now, slope. Slope is 1 over what? Rise over run. But if run is 1, then slope is rise, right? Basically, the slope indicates the marginal change. Remember, that's one of the key applications of slopes or derivatives. The notion of marginal change, like marginal profit, okay? Like your marginal change in profit, basically, right? Okay. The idea being that the rise is the same as the slope. Okay. And what's slope in calculus? It's the derivative. So the rise equals slope. That's P prime at X, whatever that value for X is. Now, of course, the tangent line only approximates the curve. We're hoping they're close, but there's going to be a difference, right? It's just an approximation. But the idea is that the derivative helps to approximate what your rise is going to be here. Okay, it's not going to be exact. It may not be exact, but it's supposed to be a good approximation. So that's the basic application of economics. When you hear about marginal profit, marginal cost, marginal revenue, you're hearing about the derivative, and it's a relationship with marginal change. So it's very much related to that differential stuff, that linear approximation stuff we did back in 3.5. By the way, speaking of marginal profit, okay, so what are some strategies regarding marginal profit? And right now we're thinking of local optimization, doing local searches, right? But what's basically the idea? All right. So here's the graph of y equals P of X. It's the graph of some profit function. Okay. All right. You can go on, these are break-even points here and here. A break-even point is where the profit's zero. Okay, now let's say that you're over here. Okay, let's say your production level is here right now. Okay. The derivative, now what sign is the derivative going to be here? What sign? The slope is going to be what? Positive. The marginal profit here is going to be positive. Okay, so what does that mean? That means that if you produce one more thing, we think that we're going to increase our profit, right? The change in profit will be positive. Okay, so what does that imply? Does that imply that we should probably increase production or decrease production? Probably increase production, because what it's saying is, if marginal profit is positive, that means that if we increase one more item, okay, it's expected, we're approximating, that we're going to make more money. We're going to increase our profit. And we're thinking, maybe even 2 or 3 maybe, right? Maybe a chance. All right, but the pressure is to increase your production level. Now, what if you're over here? Okay, over here. What sign is the derivative here? What sign is marginal profit? Marginal profit is negative. Okay, so are you inclined to increase or decrease production there? Decrease. Okay, because the idea is that if you increase production, okay, you're going to be losing money. Actually, your net profit is going to decrease. Okay, so your inclination is to decrease profit. So what would be a good equilibrium? Well, it would be really nice if we're up here. And what's the marginal profit up there? Zero. Marginal profit is 0. So in economics, you're going to find that they're going to say, we're going to look for a place where marginal profit is 0, because we're hoping that profit is maximized there. Hopefully maximized, not minimized, but we're hoping that profit is maximized there. Right? The idea that marginal profit is 0. Meaning that we don't want to budge, right? We don't want to increase production. Now, you might ask, well, wait a minute. Well, wait a minute. What if we have something like this? Okay, well, we don't know. Okay, we're doing local searching. We're not accounting for absolute extrema. We're talking local searching here. Right. So, yeah, maybe you're missing the big peak over there, but normally profit functions don't work like that. All right, fair enough. So, some basic ideas from economics. And the back of that page, don't worry about that. All right. Okay, any questions? Any questions?